As the latest phase of the Contextual Fuzzing project, we are happy to announce the release of our technology to Windows developers as a cloud-based app testing service. Using this cloud service, developers are able to stress test their apps under a variety of real-world context scenarios before the app is released to the public. Supported scenarios include sensor inputs from the GPS, fluctuations in memory availability, and networking conditions ranging from 3G and Wi-Fi connectivity to even more dynamic contexts, such as a cellular network handoff. Using contextual fuzzing, developers can discover which scenarios lead to app crashes and performance bottlenecks, such as excessive memory consumption. Importantly, this service also provides actionable reports that not only synthesize large volumes of app test data into key observations regarding app crashes and bottlenecks, but also include the necessary test metadata to guide developers in their efforts to address the issue. In the following video, we will briefly walk through the features of the Contextual Fuzzing service, which is still in beta but has been made accessible to all Microsoft employees. Using the service is easy. First, a developer uploads the app package to the service. Next, the developer can decide to either manually choose which context tests are performed, or alternatively, let our service automatically choose a custom set of conditions to try. Automatically selected tests are dynamically chosen to maximize the amount of bugs and performance issues discovered given the amount of testing time allocated. In this demo, let's manually select a few networking conditions and GPS sensor locations. First, we select a network condition. Finally, we add 2 GPS locations to be tested. Once we are finished, we create our testing task and submit it to the cloud. The task we just created has been added to the user's test queue. Contextual fuzzing supports test execution in real devices and virtual machines. In this beta version of the service, a pool of virtual machines launch the submitted app and test it under simulated user input and context conditions. For example, repeatedly performing the same user action within the app under different contexts, such as different amounts of available memory. Here we see the operation of one machine in the cloud pool. We have enabled logging on the VM, allowing us to view the steps performed by this machine. During testing, system performance counters such as energy, memory, and CPU usage tied to app activity are monitored, as well as the occurrence of any app crashes. After all tests are complete, the user is notified and a report is generated containing actionable insights. Reports contain both statistics regarding crashes that occurred during testing, as well as performance analysis. The usage reports present resource consumption for the app under different contexts, as well as in comparison to a group of apps, algorithmically selected as similar by the service, that serve as a performance benchmark. This benchmark allows developers to compare the usage of their app against other related applications. The report provides key pieces of information such as error code or exception, stack trace, and context test when the crash occurred. Additionally, screenshots of the app immediately before the crash are available, as are the precise sequence of user inputs that led up to the incident. Finally, through integration with Visual Studio, the developer can download the crash dump for further investigation of the problem. Thanks for watching. For more information about the Contextual Fuzzing project, please visit our website.